Okay, let's enter the Tidyverse. I'm using the script entitled Import and Visualize in Tidyverse, and that I made available to you on the overview of the Tidyverse function. I realize that some of the information I'm going to be showing you is in scripts, not in notebooks. That's because I'm utilizing some of the information from the last time I taught the course and haven't updated all of these to the notebooks. I did a different order last year in which we learned notebooks right at the end, and then later I realized that that was kind of foolish. I need to teach them that after they got a little bit of a handle on R, and so of course we did it in our class in the middle, but I still have some leftovers, so just bear with me. I don't think it's going to detract from your learning at all, but eventually I need to convert these all over to notebooks. Okay, so make sure you have the library loaded. And if you don't, mine's already was loaded, but if yours doesn't, you'll see a bunch of messages that it's loading. First thing I'm going to do is read in our old friend HSB2. And it might look here like I'm reading it in the same way as normal, at least the way I normally do, using the here library, so I can store the data in my data folder and have it separate from my code. But other than that, it might look the same as always, but it's not. Notice something. This is not read period CSV. It's read underline CSV. This is a Tidyverse function, and it does something different. Let's see. Notice that when we read it, it was not silent. It actually gave us some feedback here. When you use the read.csv, it's silent. But here, it gave us feedback and it told us what it determined was in each column. Now, if you remember in the HSB2 data that things are stored numerically, even for gender, even for race, SES, school type, and program. And so when it looks and sees numbers, it thinks that those are numeric, and in fact, it stores them as doubles. So that means whether it's integer or a real number that's non-integer, it's going to take and store these as doubles. So it basically tells us what our variables are and what type each variable is. This is part of the philosophy of the Tidyverse, is that feedback should be given to the individual who's creating the script to let them know if they're getting what they think they should be getting. Okay? I can already tell you, without viewing the data, I can tell you that we have, we're going to need to change some of these to factors. We can, of course, view HSB2 in the usual way with the view function like this. But notice what happens if we type HSB2. You'll probably recall that every time you type in the name of the data, you get all the data back. But that's not the case here. This is what you get. We're told at the top that this is a tibble, and we're given the first several rows. It looks like here we're given 10 rows. A tibble is a special type of data frame, and it is the data object that's used in the Tidyverse. We're going to see some of the features as we go, but we just saw one feature, and that is when you type out a tibble, it gives you all the information about your data that you're probably going to need just by printing those few rows. If you look at this, it tells us that there are 200 rows and that there are 11 variables. It's giving us the first of those variables up here, and the rest of the variables are printed down here without the data, but we can still see that they're double. We can see the type of each data. We can see the name of each data. We did not need to use type of, and we did not need to say header in order to just get the first part. Again, what is happening here is that the Tidyverse is designed to try to give individuals working within that Tidyverse the information that they need to best do the job that they need to do. I don't need to have 200 things scrolling across the screen. This is all the information that I need. Now, suppose that you were to read in your data with a routine R function. I'll go ahead and do that here. So I'm going to reread in the data. Oops, I forgot to use the here function. Let me real quick put that in. Okay, now let's read it in. And even though I don't have this in my script, let me just remind you by typing in HSB2 what we normally get. There you go. We got 90 rows of data with a message at the bottom that it omitted 110 rows. Not all that useful. If I want to use the read.csv or inadvertently use read.csv, we can still convert HSB2 into a tibble. We use as_tibble. Notice something about Hadley Wickham. And when he writes a function, he has his own style guide. In fact, I believe that when we first talked about style guides way back in the beginning of the semester, that his might have been one of the ones I showed you. I don't recall for sure. But anyway, if you look at a style guide, his names have underlines, not periods. And so this is HSB2 as underlined tibble, HSB2. And I think he does that to distinguish from our base functions, which use periods. And now if we look at HSB2, you can see we got it just as if we had used read_CSV. So I always use read_CSV, like up here, but if I ever happen to, for some reason, read in the data and it's not in a tibble, I can use the as tibble to get it into that format. Okay, so one of the packages that come in the Tidyverse package is ggplot2. ggplot2 is one of the most powerful features of the Tidyverse. That's the graphing package. So we're going to start using ggplot2. You don't have to install it because if you installed the Tidyverse, it's already installed. And no surprise, the primary function in ggplot2 is called ggplot. So here we're going to have ggplot, and the first thing that we put into ggplot is we tell it what tibble we're going to be using. So the tibble we're using here is HSB2. We've already read it in as a tibble, or we've converted it to be a tibble. And so we tell it that our data is going to be HSB2. Once we've told it we're going to use the ggplot and we're going to use the HSB2 data, the plus sign is used in order to then start telling what features we want in our plot. So there are a variety of functions we can use to plot different features. There's a link on Blackboard to a cheat sheet for our gggraphics2 and ggplot2. And if I were you, I would get all those cheat sheets that I printed out, put them in your notebook. You're going to use the graphics one quite a bit. So one of the functions we're going to use, that's a common function, is geom point. As the name suggests, and you might have guessed this, this is going to put points on our graph. So our points are then going to have, in this particular case, we're using this mapping aesthetic, and AES stands for aesthetic, so we're mapping on an aesthetic. This all sounds confusing, but when we go through the language of graphics, I think it will help clear things up. But for now, you can just kind of copy what I'm doing. We're going to tell it which variable is on the horizontal axis, that's our X variable, and which variable is on the Y. So all I'm doing here is mapping on points onto my plot where X is the reading and Y is the math. Notice we don't have to say HSB2 $ read and HSB2 $ math, because we already have indicated that this is the HSB2 data. So let's go ahead. I'm going to open my plot window a little bigger for running this. And let's go ahead and run this. And what you get is a simple scatter plot. Now, that might have seemed complicated to you, but notice a few things. You have an aesthetically pleasing background. You have the labels put on there for you, and we'll see how to change those further if we want. You have appropriate scales created for both the X and Y axis, and you have these points that are very easy to change how they look if you so desire. So as we go through, you'll see how to tinker with this to get it to do what you want it to do. But that's your first graph. Obviously, I showed you a lot in the demos, but this is the first one. You should be thinking now about, okay, if I need a scatter plot, here's what I need to do. When we learn next week about the language of graphics, you'll see how if you start incorporating that language, you don't have to memorize really anything. You just use that language to create whatever you want to create. But that's another story for another day. For now, I'm going to stop and put this video up on Blackboard, and then I will see you in the next part.